Now, this problem is different than the other ones because this is what's known as logarithmic differentiation, because x is in the base and the exponent. If x is in both places, and it doesn't matter what type of x, just as long as there's an x somewhere in the base and somewhere in the exponent, it's logarithmic. So my first step is natural log of both sides. Next step is to use my rule that says if I have something natural log with an exponent, I can bring it out front. So I'm going to bring the 2x plus 3 out to the front. It will help if right now you put parentheses and underline. That's because my next step is the derivative, and we've got to use the product rule. That's the most common mistake on these, is not using the product rule. So we're going to do the derivative implicitly. So anytime I take a derivative of y, I'm going to put dy dx, and then I have the product rule. Derivative of the first times the second, plus the derivative of the second times the first. Now, since I'm doing the derivative implicitly, after I've taken the derivative, my next step would be to solve for dy dx. That's easy because I can just put the y to the other side. Oops, x. And then, and this is important because it's going to count it wrong if you don't do this. You cannot leave the y here. The problem started out with just x's on the right hand side. Your answer's got to have just x's in it. So all you do is replace y with what it really equals. So, and remember, with WebAssign, when I enter it, I have to put parentheses around the argument of the natural log. And I'm done.